Okay, so 4.8 part 2, I'm going to give you one more aspect of a function, okay? So functions can be defined as odd or even. I'm going to write even or odd. Even, odd, or actually it could be none of the above, okay? So let me explain what each of these are. For a function to be even, okay, what it means is that it's symmetrical visually or graphically. It's symmetrical over the y-axis. So if you had a graph and you were able to fold it in half vertically and it matches itself, it would be even. So that's the graphical visual way of describing it. The algebraic way of showing that a function is even is if you put in negative x into the function, you'll get out back the original equation. All right, so that's how we define an even function. Now, an odd function you would think would be symmetrical over x-axis, but it's not. It's a little bit more complicated than that. It's actually symmetrical. For a function to be odd, has to be symmetrical at the origin, or 0, 0. So there's two ways of thinking of this. You can reflect it over the y, and then reflect it over the x. So it's a two-part reflection, or you can rotate it 180 degrees at the origin. And we are going to play with these kind of symmetries in class. All right. Now, algebraically, to show that a function is an odd function, all you have to do is throw in negative x and see if you get the negative version of the original function. All right. And then, of course, neither only happens when none of the above occurs. Okay, pretty easy. So you're going to have some homework that says, show that it's even, odd, or neither. Okay, so let me go ahead and give you two examples. Okay, let's go ahead and say we have a function, and let's see if it's odd or even. Okay, so let's start with f of x is equal to x to the third minus 12x. Okay, so I'm going to do an even check. Even check. So if it's an even check, that means that I have to put in negative x into the function. So every single place I see x, I'm going to put in negative x. Okay, and I'm going to clean it up. So I know negative x to the third is going to be negative, because anything to the third power that's negative is negative, and then this becomes positive 12x. Now the question is, if it's even, okay, then the negative version of this is going to yield the original equation. So is this equal to that? No. Okay, so my conclusion is that it's not even. All right, so let's do an odd check. All right, now if it's an odd function, then if I put negative x into my function, I should get the negative version of the original. So the negative version of the original would be negative x to the third plus 12x. Well, look what happens. Negative x to the third plus 1. I've already done that. So this is the negative version of that. So it is odd. Does that make sense? So just because it's not even doesn't mean it's necessarily odd. So as we tested it, we found out, well, in fact, it does fit the definition of being an odd function. So it is an odd function because negative x to the third plus 12x is the negative version of the original. All right, let me give you one more example, and I'm going to stick it on the side over there. Okay, let's say we have g of x is equal to x to the fourth plus x squared minus 7. Okay, so I'm going to do the even check. It doesn't matter. Let me just try the even check first. So I'm going to plug in negative x, and when I do that, I get negative x to the fourth plus negative x squared minus 7. And if I clean it up, negative x to the fourth power becomes positive x to the fourth. And then this becomes negative x squared becomes positive x squared, and this becomes minus 7. Okay, so I'm going to stand back a second and say, wait, if I plug in negative x, I end up with this, and this was my original g of x. So it looks like they're the same. And so if I plug in negative x and I get the original, then it is an even function. All right, and I don't need to go any further. So give it a try. You might have to test even, and if it doesn't work, test that it's odd, and if doesn't work, then it's neither. But if you're lucky in this case and you test it and you figure out that it's even and not odd, you're all done. If you have any questions, just feel free to post it on Google Classroom, and we'll collectively see if we can figure it out.